I've been asked to do a problem on the balances, mass balances on multiple units, and that's the topic of this video. I'm going to do a problem from Felder and Rousseau, one that is solved there as an example. And this is a complex problem of a two-stage extraction process. So this is the problem. The two-stage extraction process shown below is used to separate a 50-50 weight percent mixture of acetone and water. The extraction solvent is MIBK, methyl isobutyl ketone. For every 100 kilogram of fresh feed, 100 kilogram of MIBK is added to stage 1, and 75 kilograms MIBK is added to stage 2. Calculate the flow rates in all compositions of all named streams. So this is a problem in which the flow diagram is given, and there's additional information down here in the bottom left. So we know something about the inlet feed, we know its flow rate and composition, we know a little bit about this extract stream, we know everything about the composition of this extract 2, and this one called raffinate 2, we know the flow rate and the composition. So before we begin to try to tackle this problem, let's talk a little bit about what it is so that we can sort out what's in every stream. And this is an extraction. So let's talk a little bit then, therefore, about liquid-liquid extraction. Liquid-liquid extraction is a chemical process unit that takes a mixture of liquid feeds and uses an extracting solvent to separate those the materials that are in the feed. So in our case, we have acetone and water in the fresh feed, and we add MIBK, and at the end of the day, it mixes and forms two phases in the settler, and a phase at the top that's water-rich, acetone, water, MIBK, but mostly water, forms at the top, and then a stream with acetone, water, and MIBK forms at the bottom, but it's mostly MIBK. So adding the MIBK allows a phase to be formed that draws the acetone out of the water, and so it allows us to produce this, perhaps you would think, more complicated stream, but one that's easier to separate than the initial one, acetone and water. This is then sent to a distillation column, for example, to separate the acetone and the MIBK. So knowing this about liquid-liquid extraction helps us to interpret the flow diagram, because the flow diagram has two of these extraction units, a mixer-settler unit, and we have fresh feed contacted with MIBK settling, producing two streams. The top one is higher in water, the lower one higher in solvent. The one that still has water in it is subjected to more fresh solvent and again allowed to settle. And then that water phase is taken off and dealt with. The extract phase, the solvent-rich phase from both of the settlers, is combined and sent off for separation. Okay, now we know that every intermediate stream here has all three chemicals in it, acetone, water, and MIBK, and it's time to try to do some balances. Now really, I think the first step in a multi-unit process is always to do the overall balance. And so by the overall balance, I mean looking at the whole system as a single process, a single black box with streams going in and out. So in order to do the balance on this, I'm going to redraw it, just labeling the process in a simple way so that I can keep track of the balances. So I'm going to start over and draw something I'll just call the process. And referring back to the initial diagram, I'm going to put in a fresh feed, two MIBK streams, and two exit streams, the raffinate and the one that goes to the distillation column. So by redrawing it, I make a lot of room, and it allows me to label it accurately. So this one is the 100 kilograms MIBK, and this is the 75 kilograms MIBK. This is raffinate 2, and this is the stream that goes to the distillation column. Now the raffinate 2 stream, we know quite a bit about here. We know that it is 93% water, 5.3% acetone. So I can figure out the composition of MIBK, 93.1, 5.3, and it's 1.6% MIBK, since they have to add to 100. I can also multiply these together, so if I want to know how much water there is in this raffinate stream, I can take 43.1 kilograms total times 0.931 kilograms water per kilogram total to get the total amount of water. So the total amount of water is 43.1 multiplied by 0.931, and I get 40.1261 kilograms water. So that I'm going to put over here. 40.1261 kilograms of water. And there's 43.1 kilograms total. And I'm going to do that same calculation for the other two components of the stream. 5.3% of 43.1 is 2.2843 kilograms of acetone. And then 0.016, 43.1, 0.6896 kilograms of MIBK. Let me fix this little mistake here with my eraser. There we go. Not working so well today. Okay, so what we have now is everything that we know about the overall process. Excuse me, I didn't finish labeling. This is 100 kilograms total, and it's 50-50 acetone water. So that must be 50 kilograms acetone and 50 kilograms water. And this stream must be water, acetone, and MIBK, but I don't know in what proportions. So I can already see that I'm going to be able to do an overall mass balance since I know the mass flow rates of all but one stream. And I'm also going to be able to do balances on acetone, MIBK, and water. So we're in good shape to find out a lot about this bottom stream here, the one that goes to the distillation column. So in order to proceed, I'm going to give some labels. I'm going to call Q1 the number of kilograms total. I'm going to call Q2 the number of kilograms of water, Q3 the number of kilograms of acetone, and Q4 the number of kilograms of MIBK. So let me put some labels on so that I can put these in order for you later. Now let's do the balances. So I'm now going to do an overall balance. So the overall balance is mass in equals mass out. And so the mass in is 100 plus 100 plus 75. And the mass out is 43.1 and Q1. And so we now know Q1. $231.9 kilograms. We're going to do the balance on water. 50 kilograms comes in, 40.1261 come out here, and Q2 come out there. So water balance. 50 kilograms come in, 40.1261 come out, Q2 comes out, Q2 is 9.8739. Acetone balance. Acetone balance, 50 come in, 2.2843 come out, and Q3 come out. 50 come in, 2.2843 come out, Q3 come out. Q3 is equal to 47.7157. And finally, MIBK. The MIBK balance is 100 plus 75 come in, 0.6896 come out, and Q4 comes out. 100 plus 75 equals 0.6896 plus Q4 equals 174.3104. Now I'm going to take a pause because I want this video to end. No, I don't want it to be too long, but I want to point out that we have now solved for this stream entirely, and we knew these streams already. So we now know all of the outside streams, which is very handy. Now the next thing we're going to do is move inside, and it'll be the next step, which is probably the trickiest part, because we have to decide which balances to do next. So I'm going to do that at the start of the next video. One final comment is, I've been keeping a very large number of digits in my answers, and I've done this deliberately because I don't want any round-off error in my answers. If I were doing this problem in a computer, it would have really a very large number of digits, and that would increase the accuracy of the calculation. And so in order to not have the round-off error propagate into the numbers I care about, I'm going to keep a lot of extra digits. But when I report my answers at the end of the day, I'm going to truncate to the correct number of sig figs. So to see the rest of the solution, please go to the next video in the series.